A sudden mechanical failure under extreme tension on the water is loud, fast, and results in a lost fish. Biophysical failure on the water is entirely different. A trouble hook embedded near a tendon requires an emergency room and a surgeon. We tend to think of fishing as a passive, relaxing weekend hobby. In reality, you are managing a highly active mechanical and biophysical system that demands precise optimization. A common mistake is buying gear at random off the shelf without understanding the underlying physics. When you mismatch your rod, reel, and line, you introduce constant friction into your casting mechanics. That translates into bird's nest tangles, frequent broken lines, and ultimately empty coolers. The stakes escalate when you venture into isolated environments. Operating miles from the nearest road without a field trauma or risk management protocol is a massive vulnerability. The dilemma is straightforward. You need a system that matches your current skill level, prevents mechanical breakdown, and keeps you safe when professional medical help is hours away. Achieving that requires aligning three specific pillars: your mechanical delivery systems, your knot tribology, and your medical field readiness. We start with the mechanical delivery system. This is your rod, your reel, and your line. Historically, simplicity was the only metric that mattered. You had a stick, some string, and a hook. Today, the standard entry-level setup is a spin cast or spinning reel paired with monofilament line. Monofilament line offers high stretch. That elasticity acts as a shock absorber, making it highly forgiving for beginners when a fish strikes aggressively. But you pay for that forgiveness by sacrificing tactile sensitivity and casting precision. Anglers looking to optimize their performance often upgrade to a bait casting reel paired with braided line. The physics here shift dramatically in your favor. A revolving spool combined with zero stretch braid gives you extreme winching leverage. You can feel the slightest underwater vibration transmitted directly to your hand. But the penalty for a mistake is severe. If you fail to manage the momentum of that revolving spool, you get rotational spool overrun. In a fraction of a second, 50 yards of line becomes a useless knotted nest. Avoiding that catastrophic tangle means you have to master active tactical thumb braking. You literally use your thumb against the spool to control the line velocity during the cast. Choosing a delivery system is a calculated trade. You either accept lower tactile performance for the safety of a forgiving reel, or you risk catastrophic spool overruns to gain the winching power of a bait casting rig. Once you select your delivery system, you have to attach your tackle. This brings us to the knot. The knot is a point of structural isolation. It is the single weakest link where line failure is most likely to happen. The improved clinch knot is the most common and familiar knot taught to anglers. This chart tracks knot structural integrity. With light monofilament under 30 pounds, the improved clinch maintains 90. If you are throwing massive swim baits, you end up cutting away and wasting a massive amount of premium line every time you tie on. Buying the strongest fishing line on the market accomplishes nothing if your knots are poorly matched to your line material and lure size. In backcountry environments, the stakes move from lost fish to personal safety. When you operate miles deep in a river canyon, environmental risks are high and medical help is inaccessible. Your first line of defense is polarized sunglasses. They cut glare to help you spot fish, but they also act as physical shields, mitigating catastrophic eye trauma from heavy lures flying back at you on errant casts. Even with eye protection, the most common acute field trauma you will face is an embedded fishhook. This flowchart outlines a strict hook removal triage protocol. Following the flashing red path for red flag zones, like eyes, joints, or major blood vessels, you must evacuate to an ER immediately. The green path covers fleshy areas, where the DIY string-yank method is authorized for field removal. You loop a heavy piece of line around the hook's bend. Applying firm downward pressure on the eye pivots the metal, clearing the barb. Then a sharp pull on the string cleanly backs the hook out the way it went in. To safely manage these situations, carrying a dedicated set of heavy-duty wire cutters is a non-negotiable requirement. Sometimes pushing a hook through and cutting off the barb is the safest path forward. True field readiness requires you to treat your medical triage knowledge and trauma gear with the exact same scrutiny as your rod and reel. This 3D quadrant chart maps your ideal tactical loadout. By plotting the effort and skill required against overall tactical effectiveness, we can match your gear to your specific needs. Profile 1 is the friction-averse beginner. If you prioritize ease of use over raw power, you live in this lower left quadrant. Your ideal loadout consists of an open bail spinning rod, light monofilament line, and the improved clinch knot. This is the optimal setup for targeting small, shy fish like trout or panfish. Your strategic advantage is high accessibility. You get immediate water readiness, zero casting frustration, and skip complex knot theory entirely. Profile 2 is the systems optimizer. If you are hunting agile, heavy predators, you operate in the upper right quadrant. Your loadout requires a baitcasting rig, heavy braided line, and the Palomar knot. This system is purpose-built to survive the extreme mechanical load of winching massive targets out of heavy cover. The trade-off is time. You gain unmatched winching power and tactile sensitivity, but you must invest hours of practice training your thumb to break the spool perfectly to avoid catastrophic tangles. Profile 3 is the risk mitigator. This is the backcountry angler operating in high-stakes environments where help isn't coming. Regardless of rod choice, this loadout mandates insulated hydration systems to manage heat, polarized lenses to protect the eyes, and dedicated wire cutters for immediate trauma response. Building your optimal rigging system isn't about buying the most expensive gear in the shop. You achieve optimization by ruthlessly aligning your mechanics, your knots, and your trauma readiness with your actual environment and skill level.